Welcome to our third video for AP Statistics. This is again analyzing categorical data. We are working with two-way tables today. So our essential question is, what type of information is displayed in a two-way table? So let's first begin with some terminology. What is a two-way table? Well, you've worked with tables before in here, but a two-way table is a little bit different in the fact that it displays two categorical variables for a group of individuals at a time. So it's not just rows of individuals with columns of variables, but it is allowing for two categorical variables to be compared side by side in terms of the same set of individuals. With a two-way table, we can come up with what's called a marginal distribution. And the marginal distribution, we take the row and column totals and use the individuals out of the whole, the row and column totals out of the whole set of individuals. The marginal distribution is addressing only one of the categorical variables in the two-way table. And then we also have what's called a conditional distribution. And the conditional distribution is going to describe the values of a variable alongside another variable. So it's going to allow us to compare the individuals in a set to one another based on two different categorical variables at the same time. We'll get into how we're going to do that in just a minute, but let's just make sure that we've got these terms in our notes so that we can move forward as to an example of how we do that. Okay, for a two-way table, this is an example of a two-way table. We have 200 children from the United Kingdom that were surveyed from ages 9 to 17, and the breakdown of those is displayed in this table. But notice, the rows are one of your categorical variables in terms of what superpower those children would like to have, and the columns is another categorical variable, whether or not the students are male or female. So they're broken down based on gender in the columns and by superpower preference in the rows. So we are able to see two different categorical variables side by side. Then we have the row totals and the column totals, and then of course it all adds up to the total individuals in this set of data, which is 200. Okay, we're going to take this information and model what is called a marginal distribution. So, if I want to know the marginal distribution for this set of data in terms of superpower preferences, so that's your number one here. In terms of superpower preferences, what is the marginal distribution? So I'm not going to look at the males and the females separately here. That is not the categorical variable that we are working with. We are working with the superpower preference. So we're working with the totals out of the entire students. So when we're talking about the marginal distribution, we're doing this as percentages of the whole. So invisibility. 30 out of 200 selected invisibility, and we can come up with a percentage for that. 20 out of 200 preferred super strength, and we can produce the percentage when we perform that computation. So those were 15 and 10% respectively. And let's look at what happens when we calculate also for telepathy, flying, and freeze time as well. We should come up with this marginal distribution. So when 30 out of the 200 preferred invisibility, that produces 15% of the entire group preferred invisibility, and so on and so forth. The this marginal distribution is going to allow us to compare the conditional distribution to it later on in order to see whether or not another variable has an effect here. Does it matter whether or not the student is male or female as to which superpower that they picked? So this is a marginal distribution table, and with that table we can produce a graph. When we make a graph to match up with that marginal distribution table, it's going to look something like this. So we've got the percentages in terms of preference up here, and then we've got the superpower preference listed down here. So we see that 15% preferred invisibility, super strength was preferred by 10%, and so on and so forth. And that matches up with our table. So that's our number 2. Okay. For number 3. Can we conclude that boys and girls differ in their preference of superpower? In order to do so, what we need to do is calculate the conditional distribution. So when we had the marginal distribution, we calculated their percentages based on the individuals who picked invisibility out of the total, the individuals who picked super strength out of the total. Well, with the conditional distribution, we're not going to have one percentage column, we're going to have 2, and each one is going to represent a different categorical variable, namely, in this circumstance, female and male. So we want to know of the population that of the sample that we took, 17 out of 115 females preferred invisibility. 3 out of 115 females preferred super strength. 39 out of 115 preferred telepathy. 36 out of 115 wanted to fly. And 20 out of 115 wanted to freeze time. We're going to do the same thing with the males. So we're going to end up with 2 columns in our conditional distribution table, like so. So when we perform those calculations, the 17 out of 115, we get 15%. And for the males, when we performed 13 out of 85, we came up with, again, 15%. And that's how you construct a conditional distribution table. We can also graph the conditional distribution, and it's going to be, if we do a bar graph, very similar to the bar graph we did before, except we're going to have 2 different bars being compared side by side for each of these superpowers. So let's look at what the graph for that is going to look like. Here we see that both males and females preferred invisibility at the same percentage, which was 15%. However, we see that super strength, the males preferred the super strength over the females. That's a significant difference. As well as telepathy, the females preferred that significantly to the males. And then flying was not exactly too different. It was close, closer than the others. But freeze time was also different. The males preferred that to the females. So as we can see, gender clearly does have an effect on whether or not the students prefer a particular superpower. And we can also compare that to our table that was our marginal distribution to see the difference that it makes to compare 2 variables at the same time. So now I'm going to give you the opportunity to figure out a conditional and a marginal distribution. I want you to try out the candy factories A and B in example 2. Now, as you see, my table is a little bit off here, as well as your table is. So just so that we're on the same page, I want you to note that the number of spearmint packs of gum produced by factory A is 250, and the number of spearmint packs of gum produced by factory B is 175. So you've got to move that 175 over, as well as the 180 over in order for it to be the amount of cinnamon packs of gum produced by factory B, and the wintergreen, move that 25 over so that it's in the right spot. Sorry for all the formatting. We will work on it together. We will go over what results you get for your example 2. Again, do exactly what we just did with example 1, but this is your chance to try it out on your own, and we will start on it tomorrow. Please bring your book to class. If you don't have it yet, that's fine. But if you do have it, bring it to class. It will help us have a reference and other examples as you are going through the two-way tables activities that we're doing tomorrow. Thanks, and we'll see you tomorrow in class.